Good day, Math Buddies! Sir Sherwin here, your math instructor. Welcome to another content where we are learning mathematics lesson in an exciting and interesting way. And for today's video, we will be learning on how to simplify rational algebraic expression. But first, please don't forget to subscribe on my YouTube channel and hit the notification bell for more updated contents. Alright, dear math buddies, as what we mentioned a while ago, today we will be learning on how to simplify rational algebraic expression. But first, let's try to have a short review. In our previous video, we've learned on how to define fraction or rational numbers as numbers written in the form p over q, where p and q are integers and q is not equal to 0. Here, p is our numerator and q is our denominator. Among the examples of fractions or rational numbers are 1/2, 1/3, 2/3, 1/5, and the like. On the other hand, when we are talking about rational expression, we are referring to an expression written in the form p over q, such that p and q are our polynomials, and q is not equal to 0. So let me present to you an example of a rational expression. Alright, here are some of our examples of rational expression. First, we have x squared plus 3x plus 2 all over x plus 4. In this certain expression, our numerator is composed of a polynomial x squared plus 3x plus 2, which is a quadratic expression. And our denominator is x plus 4. In our first example, remember that x must not be equal to negative 4. Because if our x will be equal to negative 4, it will lead us to a denominator which is 0. Remember, in a fraction or rational expression, a denominator that is 0 will be undefined. Another example, 4x squared minus 9x plus 3 all over 2x minus 3. In this certain rational expression, 4x squared minus 9x plus 3 is our numerator, and 2x minus 3 is our denominator. Here, in this example, x must not be equal to 3 halves. Again, if our x is 3 halves, it will lead us to a denominator of 0. And our expression will be undefined. For the third one, we will have x plus 4 all over x minus 2. Here, x plus 4 is our numerator and x minus 2 is our denominator. And x is not equal to positive 2. Because if our x is positive 2, it will lead us to a denominator which is 0. And again, our expression will be undefined. So our task now is to simplify our rational expression. The question is, how will we simplify rational expression? Let us try to find out. So first, let's try to remember some of the significant ideas in simplifying rational expression. Some of the polynomials are written as product of 2 or more factors. When a rational expression has the same factors in the numerator and in the denominator, then it can be simplified by dividing both our numerator and denominator by their common factor. A rational algebraic expression is considered to be simplified or written in its simplest form if our numerator and denominator has no common factor except 1 or negative 1. So with this, let's try to have our first example. So first, we have 4/18. Here, we can simplify 4/18 by looking for their common factor. So if we are to write possible factors of 4 and 18, that is, for 4, we have 2 times 2. And for 18, we have 9 times 2. And here, we noticed that both numerator and denominator has a common factor, and that is 2. So this is their common factor, and we can divide both by their common factor, which is 2. So we can eliminate their common factor, which is 2, and the result will be equal to 2/9. And this is the simplified form of 4/18. Another example. 25/35. Here, our numerator is 25 and our denominator is 35. To simplify this, let's try to look for their common factor. So 25 has factors 5 times 5 and 35 has factors 7 times 5. In this example, we have a common factor both in numerator and in the denominator, and that is 5. So we can cancel this out. So what is left is 5 as our numerator and our denominator, which is 7. The simplified form of 25/35 is 5/7. This time, let's try to have our third example and let's try to engage variables. So we have x squared plus x all over x squared plus 5x. Remember, we cannot directly eliminate x squared because our expression is separated by addition sign. So we cannot eliminate x squared in the numerator and in the denominator. But instead, we will try to factor it out. So first, let's try to factor x squared plus x. So common between x squared and x is x. So we can factor out x. So x squared plus x has factored terms x times quantity x plus 1. Because if we apply distributive property, it will lead us to x squared plus x. This means x times x, that is x squared, x times 1, that is x. Same as true with our denominator, which is x squared plus 5x. So we can factor out first x, and the other factored term is x plus 5. In this case, we notice that our numerator and denominator has common factor, and that is x. So we can cancel out x this time because it is considered as common factor of numerator and denominator. So our simplified form would be x plus 1 all over x plus 5. Let's try to have another example. We have x squared minus 4 all over x squared plus 5x plus 6. So here, we cannot cancel out directly x squared, even though they are both present in the numerator and in denominator, because they are separated by a subtraction sign in our numerator and addition sign in our denominator. So we cannot eliminate it directly. If we noticed, our numerator is an example of a spatial product, while our denominator is a trinomial. So how will we simplify this kind of expression? So first, let's try to factor out x squared minus 4. Since it is a spatial product, preferably a difference of two squares, this means it can be factored out as quantity x plus 2 times quantity x minus 2. On the other hand, our denominator is x squared plus 5x plus 6, and it is a trinomial. Let's try to think of possible factors of x squared plus 5x plus 6. So here, we will have two binomials. Because our second term and third term are both positive, this means our binomial is separated by plus sign. First, possible factors of x squared would be x times x. And possible factors of 6 that if combined is 5 would be 2 and 3. This means if we apply FOIL method, x times x, that would be x squared, x times 3, that would be 3x, 2 times x, that would be 2x, and last terms 2 times 3, that is positive 6, combining 3x and 2x, that would be our middle term, which is 5x. So this could be considered as factors of our trinomial. And if we noticed that x plus 2 is both present in the numerator and in the denominator, this means this is the common factor of our given expression. So we can cancel out x plus 2. What is left is x minus 2 all over x plus 3. Again, we cannot eliminate x even though they are both present in the numerator and in the denominator because they are separated by subtraction sign and addition sign. So, we will have this one as our final answer. X minus 2 all over x plus 3. Let's try to have the fifth one. So our given is x squared plus 3x plus 2 all over x squared plus 5x plus 4. And thus, rational expression, we have the numerator which is a trinomial and a denominator which is also a trinomial. And let's try to look for possible factors of our numerator first. X squared plus 3x plus 2. So possible factors of our trinomial would be two binomials. It is a result of two binomials because our expression in the second term and third term are both positive, then we will have plus sign separating our two terms in every binomial. So let's try to look for factors of x squared. So preferably the factors of it would be x times x. And possible factors of 2 that if combined or added becomes 3, that is 1 and 2. Of course, we can write interchangeably 1 and 2. So we can have x plus 2 here and x plus 1 on this binomial. Still, we will come up with the same trinomial, which is x squared plus 3x plus 2. Likewise, same concept will be applied in our denominator. We will look for possible factors of x squared plus 5x plus 4. Again, we will have two binomials. And second term and third term are separated by plus sign. It follows that our binomial will be separated by plus sign as well in every terms in this binomial. So first, possible factors of x squared, that would be x times x. And possible factors of 4, that if combined becomes 5, would be 1 times 4. We can write interchangeably x plus 4 and x plus 1 in this factored terms because still it will lead us to this trinomial. So we can automatically cancel out x plus 1 because they are both present in the numerator and in the denominator. And our simplified expression would be x plus 2 all over x plus 4. Again, we cannot eliminate x here even though they are both present in the numerator and in the denominator because our expression is separated by plus sign. So, this can be considered as our final answer. Another example. We have ax plus ay plus bx plus by all over a squared plus 2ab plus b squared. So here, we will try to factor our given expression. Let's start with the numerator. In factoring our numerator, let's try to group it first. Let's try to think of the possible terms that can be grouped and can be factored out. So in this case, we will try to group ax plus ay. So we will have ax plus ay plus, this will be the plus sign, then group also bx plus by. Then we will try to copy first our denominator, which is a squared plus 2ab plus b squared. So I need to group first our numerator according to the similarities they have. It is for us to factor out easily our given expression. So in our first group, quantity ax plus ay, we have a common factor, which is a. And the other factor is x plus y. Because if we apply distributive property, it will lead us to ax plus ay. Then copy the plus sign. And the common factor between bx and by is b. And that is x plus y being the second factored terms. And let's try to also to factor out this trinomial a squared plus 2ab plus b squared. So possible factors of this trinomial would be two binomials. So our terms in our binomial will be separated by a plus sign for the reason that our second and third term are both positive. Factors of a squared would be a times a, and factors of b squared is b times b. Our second term is a result when we combine our outer terms, which is ab, and inner terms, which is also ab. If we add this two, it will lead us to 2ab because every expression here has a numerical coefficient of 1, which satisfy our second term. Let's try to continue our solution. So if we noticed our numerator, we have a times quantity x plus y plus b times quantity x plus y. Still, we have a common factor, and that is x plus y. So we can factor out quantity x plus y. And another factored term would be a plus b. We have a plus b. Then we will copy our denominator, which is quantity a plus b times quantity a plus b. And again, we notice that a plus b is both present in the numerator and in the denominator. So we can cancel it out. So what is left in our expression would be x plus y and the denominator, which is a plus b. So the simplified expression of this rational expression would be x plus y all over a plus b. So it is easier for us to simplify rational expression if we know already the idea on how to factor the given expression. There you have it. Hope you learned something new today. God bless us all.